Is it okay?
Yes, sir.
Well, relations we discussed, all the type of relations. We discussed a lot of questions. Of course, if at all a question remaining, you can bring it in my notice. Well, we go ahead with the more important topic, that is functions. The definition of function actually we have done in 11. I'm just going through once again. What is a function? Function from A to B is a relation in which every element of A is uniquely associated with elements of B. That every element of A and unique association, uniquely associated with elements of B. Anyway, that is a revisional point, so you know what is a function. So if f is a function from A to B, we write f from A to B. It is a kind of relation, the same notation. But normally for relation we use a capital R or something like that. For functions we use letters f, g, capital or small, any. If xy is a member of f, we say that y is the image of x through the function. The image of x through f is y. And we write y equal fx. Instead of in the relation we say a or b or x or y. Instead of x or y, we write y equal fx. That is the meaning of y equal fx. Y equal fx means image of x is y or xy is a member of f. For example, suppose I have a is equal to 1, 2, 3, 4 and b is equal to 1, 3, 5, 7, 9. Let me define f from A to B, f equal to 1, 3, 2, 7, 3, 9. Well, you know now the topic. Is it a function? You know it is not, because 4 in A has no image in B. There is a member 4 which has no image in B. What is the condition for a function? Every element of A must have unique image in B. Let's take another one, G from A to B. G is equal to 1, 3, 2, 5, 2, 7, 3, 9, 4, 9. Is it a function? You know it. Again, it is not. Why? Because 2 has 2 images. 2 has more than one image. 5 as well as 7. 2 belongs to A. 2 has more than one image of 5 and 7 in B. This is not possible. Two things are forbidden while we consider a function. One, first of all, there shall be no element in A having no image in B. Every element of A. And second, no element can have more than one image. Every element must have only one image. Two image not possible. Now let us take another one. H from A to B, H is equal to 1, 5, 2, 7, 3, 9, 4, 9. Is it a function? Do every element has an image? 1 has an image, 2 has an image, 7, 3 has an image, 9, 4 has an image, 9. And do any of these elements have more than one image? 1, only one image. 2, it's not 2 image. 2 has only one image, 3 has only one image, 4 has one image. So H is a function. Nothing to worry, these 3 and 4 have same image, but that's not a matter. So H is a function. And image of 1 is 5 means H of 1 is 5. Image of 2 is 7 means H of 2 is 7, and so on. That's what we mean by function. Domain, range, and codomain of function. This is again an original topic. Just like that of the relation, we have domain, range, and codomain. Let f be a given function. The domain of f is set of x such that fx is defined. Or I can say set of x where xy is a member of f. Set of x such that xy is a member of f. That is domain. Set of x such that xy is a member of f. What about range? Range is set of values of fx. Domain is set of x value, range is set of fx value. Set of fx value means set of y whenever xy is a member. That means if xy is a member of f, x will go to domain, y will go to range. X is in the domain, y is in the range. Or set of all x value will be the domain and set of all y value will be the range. If F from A to B, then codomain is B itself, nothing more. And one thing to note that I just told that F is a function. But if I say, okay, we know that range of F is subset of codomain of, because F from A to B, then range will be subset of B, and that is range is subset of codomain. One thing to note that if F from A to B is a function, if F from A to B is a function, the domain has to be A. Because the first condition for function is that every element in the set A must have image in B. That means the domain itself. I have not told here from A to B. If I say A to B, then no doubt A is the domain. So be careful. Domain, range, and codomain. Real function and real valued function. Real valued function, a function whose range is set up around real numbers or its subsets, is called a real valued function. Whereas real function is a function whose domain and range both are real numbers or subset of R is called a real function. Any question? Any question? Well, real valued functions, some real functions, these are topic from 11, nothing to worry. All real functions are very much real valued functions, but real valued function need not be real function. I'll just pick up only one example. Unless otherwise stated, we consider only real functions in our topic. The whole topic we are dealing real function. Whenever I say function, it is real function. Otherwise, I have to specify. Just I am taking one example for a real valued function. A is a set of months, January, February, etc. up to December, and I'm considering a function from A to R. F of January is 31, F of February is 28, and so on. It's a real valued function. Range is a subset of R, but it is not a real function because domain is not R or its subsets. Well, we'll discuss more later. Type of functions. Be careful about, we are going to discuss 4 types of functions. First is one-to-one function, many-to-one function, on-to function, and into. I'll explain it very clearly. First, let me define it. One-to-one function is also known as injective function or injection. One-to-one function is also known as, be careful about the names, injective function or injection. A function F from A to B is called a one-to-one function or an injection. If fx1 equal to fx2 implies x1 equal to x2 for all x1 and x2. Well, it is an implied condition. I can give a quadrapositive for the same. P implies Q. We can say not Q implies not P. That is as good as x1 not equal to x2 implies fx1 not equal to fx2. If you have distinct x1 and x2, then their images also must be distinct. If you have x1 and x2 same, different, x1 and x2 different, but fx1 and fx2 are equal, then it is not one-to-one. One-to-one means x1 and x2 are distinct, their images also must be distinct. Or you can say I will discuss it more or explain with more examples later. Okay.
Sir.
Yes.
Sir, Vasu is waiting, sir. Please let him in.
I admit it now.
Hello, sir.
Well, keep in mind, I will explain it more with diagrams later. When is it one-to-one? Actually, it means distinct elements will have distinct image. Distinct elements will have distinct image. Distinct elements in the domain must have distinct images in the codomain. If you have 2 elements having same image, it is not one-to-one. Keep the idea, we will explain more. Just I'll take one example to show it is one-to-one. So that f from R to R, fx equal to 3x plus 4x 3x plus 1 by 4 is 1. What is 1-to-1? 1-to-1 function means fx1 equal to fx2 must imply x1 equal to x2. Let us take that fx1 equal to fx2. Very simple. fx1 equal to fx2 implies what is when fx is 3x plus 1 by 4. What is fx1? 3x1 plus 1 by 4 equal to 3x2 plus 1 by 4. Does it not imply 3x1 plus 1? I cancelled 4 both sides. 3x plus 1, 3x1 plus 1 equal to 3x2 plus 1. That implies 3x1 equal to 3x2 implies x1 equal to x2 for all x1, x2 in R. So ultimately I have fx1 equal to fx2 implies x1 equal to x2. fx1 equal to fx2 implies x1 equal to x2. That means f is 1-to-1 and therefore f is 1. 1-to-1 function. fx1 and fx2 are equal invariably x1 and x2. Well, we'll take up more example later. Many-to-one function. Many-to-one function means a function f from a to b is called many-to-one if it is not 1-to-1. If it is not 1-to-1 means when is it 1-to-1? Distinct elements will have distinct image. That means if it is not 1-to-1, there will be at least one pair, x1 and x2, so that x1 and x2 are distinct, but their images are same. It is not necessary every element has same image. Many elements may have distinct image, but at least one pair of x1 and x2 will be there. x1 and x2, maybe 2 and 3, but f of 2 and f of 3 are same. These two elements have same image. One pair we can show with this, then the function is not 1-to-1, it's many. Okay, we go for simple example, f from n to n. I am defining fx like this. I define in a slightly different way. X by 2 when x is even and 2x when x is odd. According to this, what is f of 1? 1 is odd. So what is f of 1? 1 is 2 because 1 is odd, fx equal to 2x. What will be f of 2? 2 is even, f of 2. f of 2 will be 2 by 2, 1. But can you tell me what is f of 4? 4 is even. When x is even, fx equal to x by 2. f of 4 by 2, 2. Well, f of 1 and f of 2 are equal. 1 is not 4, but f1 and f of 4 are equal. That means it is not 1-to-1. If we can show at least one pair of x1 and x2 with fx1 and fx2 are equal function, many-to-one. To show it is 1-to-1, you have to precisely show by step. To show it is many-to-one, produce one example. Okay, therefore f is many-to-one. Now onto function. We have 1-to-1, many-to-one, onto function. Onto means is also known as surjective function or a surjection. 1-to-1 is also known as injective function or injection. Onto is also known as surjective function or surjection. Okay, a function from a to b is called an onto function or a surjective function or a surjection if for all y in B, be careful, for all y in B, which is B, codomain. For all y in B, we must get x in the domain. We must get x so that, x in A so that, x is equal to y. There shall be no y in B without having an x in which it is connected. For every y in B, there must be x in A so that f is y. Precisely that means every element in the codomain must have a preimage in the domain. Every element in the codomain must have a preimage in the domain. I'm again telling, I'll explain it with the diagram later. Let me complete the definition first. Every element in the codomain must have a preimage in the domain. Then only we say the function is onto. Onto function is also known as surjective function or a surjection. 1-to-1 function is also known as injective function or injection. Well, if I want to show f from R to R fx equal to 2x onto, I must show that for all y in the codomain, what is codomain R? For all y in R, I must have an x in the domain. We need to show there is an x in domain so that x equal to y. Is it possible? Let us take. Well, I propose let y equal to 2x. I've taken let y equal to x. I do not know whether it is possible or not. Then what is x? X is y by 2. What is actually y? Y is a member of R. So y by 2 is very much a real number. So one thing is true. When you produce a y in R, hello, hello. For all y in R, we must get an x in R. So I proposed y equal to 2x, and in that case, x equal to y by 2. One thing is true that y by 2 is a member of R because y is a member of R, y by 2 is a member of R. One thing is guaranteed, given y in R, I got an x in R, and what is your f of x? Fx means f of y by 2. What is f of y by 2? Look at fx equal to 2x. F of y by 2 will be 2 into y by 2, 2 into y by 2, that is 1. 2 into y by 2, that is 1. That means for all x in R, for all y in R, we got an x in R. What is that x? It is y by 2 that we calculated. For all y in R, we got an x in R so that fx equal to y. Fx equal to y. Okay? Therefore, f is on 2. Well, I will ask this question later also. If it is from n to n, will it be on 2? F of 1 will be 2, f of 2 will be 4, f of 3 will be 6. It will not be on 2 because image of 1 is 2, image of 2 is 4. There is no pre-image for 3. Okay, that we will discuss later. Keep in mind. Further is into function. What is an into function? A function f from a to b is called an into function if it is not on. If it is not on. Well, that means there must be at least y in b for which there is no x in a satisfying fx equal to y. At least some element in b must be left out, having no pre-image in x. Well, can you show that f from n to n fx equal to 2x? This is what I am discussing. F from n to n fx equal to 2x is into. What is your f of 1? 2. And what is f of 2? 4. Pre-image of 2 is 1. Pre-image of 4 is 2. Is there any pre-image for 3? There is no pre-image for 3. For y equal to 3 in n. For y equal to 3 in n. There is no x in n so that fx equal to 1. So this function is into function. Therefore, f is not onto or f is an into function. Okay. Now bijective function, which I have not discussed in the previous 1 to 4. This is bijective function. A function which is 1 to 1 and on to, that is both injective and surjective, is called a bijective function. Keep in mind, we require it later. Well, can you note down this question? You go through the definition carefully. I will discuss all with diagrams tomorrow and explain it more. Please note down the question. Find which of the following functions are 1 to 1, many to 1, on to, and into. F from R to R, fx equal to 3x minus 2. F from n to n, fx equal to x plus 1. Again, f from R to R, fx equal to x squared. F from z to z, fx equal to x plus 2. And f from n to n, fx equal to 2x if x is odd. Fx equal to x by 2 when x is even. So many of them may be 1 to 1. You have to find out which of them are 1 to 1. Many of them may be on to. You have to find out which of them are on to. And which are not 1 to 1 will be naturally many 1. Which are not on to will be naturally into. Okay. Well, this is only the beginning, not the end of the topic. You have just started the